Hello everyone, welcome to today's presentation on Unit 2 of Data Structure and Algorithm. Myself, Namita Amrutkar, and I am excited to take you through the various searching algorithms and their importance in computer science. Let's get started. Here is the agenda for our presentation. We shall start with an abstract data type, array application, then delve into linear search and binary search. We shall learn these techniques and discuss their application. Abstract data type. An abstract data type is a model for a data structure that specifies the type of data stored, the operation that can be performed on them, and the types of parameters for those operations. The key concept behind abstract data type is that they focus on what operations are performed rather than how these operations are implemented. It does not specify how data will be organized in a memory, what algorithm will be used for implementing the operation. It is called abstract because it gives an implementation independent view. The process of providing only the essential and hiding the detail is known as abstraction. The user of data type does not need to know how the data type is implemented. For example, we have been using primitive values like integer, float, character data types only with the knowledge that these data types can operate and be performed on without idea how they are implemented. So user only need to know what data type can do but not how it will be implemented. So it is an abstract data type. Now we have to learn about the array operation. As you know, array as a basic data structure. Representation of data is defined by the language compiler itself, but the operation on the data are not defined by the compiler. We have to implement or provide the operation on data. So data structure array and the set of operation together we call it as abstract data type. We can perform many operations on the array such as display operation. It is used to print the entire array. Append, to add element at the end of the array. Insert is used to element at the particular index. We can also perform a search operation to check whether the given element is present or not in the array. Get function, it will return the element which present on the given index. Set function, it will change the element with the new element at a particular index. Max and min function, these functions are used to return the maximum and minimum element in the given array. Reverse function, it is used in order to change the element in the given array. Shift, this function shift the whole element either on the left side or a right side by the given number. Now we have to learn array application. Array have a wide range of application in computer science and software development. Here we have to include some scenario where arrays are used. First one, storage and retrieval. Arrays are ideal for storing and retrieving data in a sequential manner. They can be used to store a list of name, address or any other information that require straightforward access. The second one is mathematical computations. Array is essential for performing mathematical calculations. They provide convenient way to store and manipulate set of number, making them ideal for tasks like matrix operations, statistical analysis. Third one is searching and sorting. Array are crucial in searching and sorting algorithm. Searching algorithm like a linear search and binary search operate on an array to locate a specific element efficiently. Sorting algorithms such as bubble sort, quick sort, merge sort, these sorting algorithms rearrange the element of an array to put them in a specific order. The fourth application is in dynamic programming. Arrays are heavily used in dynamic programming. It is a technique for solving a complex problem by breaking them into a smaller overlapping subproblem. One of the application of the array is searching. Searching is the fundamental process of locating a specific element or atom within a collection of data. There are two types of searching we have to learn. First one, linear search, and the second one, a binary search. Now we understand how linear search will work. Linear search is a simple method of finding a target value in a list. It works by starting from the first element and comparing each element with the target value until a match is found or the end of the list is reached. The time complexity for the linear search is order of n, where n is the number of elements in the list. Here, the simple example I have covered it. The list contains the element 10, 20, 30, 40 and 50, and we want to find the target value 30. We start by comparing 10 with 30, no match. Then we compare 20 with 30, no match again. Finally, we compare 30 with 30. We have match and return the index value 2. As we know that a binary search required a sorted array. Now we have to explore the advantage and disadvantage of a binary search. Advantage of a binary search. It is efficient, that is, a binary search has a time complexity order of log n, which makes it very efficient for searching large sorted array. It is simple to implement. Binary search is relatively easy to implement and understand. It is a versatile. Binary search can be used in a wide variety of applications. Binary search is reliable algorithm that will always find the target element if it exists in the array. The disadvantage of binary search is that binary search only works on a sorted array. If the array is not sorted, it must be sorted before binary search can be used. For large array, other search algorithms such as interpolation search or a hash table may be more efficient as compared to the binary search. Let's look about the advantage of linear search algorithm. Linear search can be used irrespective of whether the array is sorted or not. It can be used on array of any data type. Does not require any additional memory. It is well suited algorithm for a small data set. Now looks at the disadvantage of the linear search. Linear search has a time complexity order of n, which in turn makes it slow for large data set. It is not suitable for large array. Now we explore binary search. Binary search is a search algorithm used to find the position of target value within a sorted array. It works by repeatedly dividing the search interval in half until the largest value is found or the interval is empty. The search interval is halved by comparing the target element with the middle value of the search space. To apply binary search algorithm, the data structure must be sorted. Access to any element of the data structure should be constant time. Let's walk through the example to understand how binary search works. We have a sorted list number 10, 20, 30, 40, 50, 60, 70, 80, 90 and 100. And we want to find the target value 70. First, we initialize two pointers, low at the beginning of the list and high at the end of the list. Step by step, we have to explain how this algorithm will be work. We calculate the mid index by using the formula mid is equal to low plus high divided by 2, which gives the mid value is equal to 0 plus 9 divided by 2 is equal to 4.5. Since we are dealing with indices, we take floor value, so mid value is equal to 4. The element at index 4 is 50. Now compare the middle element with target value. We compare the immediate element, that is 50, with the target value 70. Since 70 is greater than 50, so the target must be on the right half of the list. Now we have to adjust the pointer. We adjust low pointer as mid plus 1, which moves to the at index number 5. We have to repeat the process until the new low and high pointer. Calculate again the middle index, that means 5 plus 9 divided by 2, now it's become a 7. The element at index 7 is 80. Compare 80 with 70. Since 70 is less than 80, the target must be in the left half of the current sublist. Adjust the high pointer to mid minus 1, which move it to the index 6. Now calculate the new middle value. Now middle value is equal to 5 plus 6 divided by 2. Now it's become 5.5. Again we have to take the floor value, that is middle is equal to 5. Correct. The element at index 5 is 60. Compare 60 with 70. Since 70 is greater than 60, the target must be in the right half of the current sublist. Adjust the low pointer to the middle plus 1, which move it to the index 6. Now both low and high pointer at index 6. Calculate the middle index. 6 plus 6 divided by 2. Now we have to get a sixth new value. The element at index 6 is 70, which match our target value. We can say that the target value 70 is found at index 6 in the list. If the target value were not in the list, the process will continue until low exit high, at which point we could conclude that the target is not present in the list. In this session, we learn about searching technique. On next session, we learn about sorting techniques. Thank you for your attention.